this video is for Math 95, and this topic is about powers and roots. Okay? And these are inverse processes in a similar way that multiplication and division are inverse processes. So to start out, let's look at the table that's on the first page of this handout. I would encourage you to complete it. It's not absolutely necessary. I'm not going to quiz you on these things, but I think that it helps you to understand how powers and roots work. Okay? So I'm going to start filling in the table here. So 2 to the first is 2, 2 squared is 4, 8, 16, and 32. With the negative 2, they'll be the same here, same absolute value, but the even powers will be the same, and the odd powers will have an opposite sign. And that'll be true for the rest of the numbers as well. Okay? Let's see here. 3, 9, 27, 81, and then 243. So this will be negative 3, positive 9, negative 27, positive 81, and then negative 243. All right, let's see here. 4, 16, 64, 256, and then what is that going to be? 1,024, is that right? I think so, yeah. So 4 to the 5th power, 1,024. There we go. And then this will be negative 4, positive 16, negative 64, positive 256, and negative 1,024. Okay, so that's just to give you an idea of raising numbers to powers. Okay? Now, in terms of order of operations, let's go back and talk about that a little bit. I think I brought this up in a previous assignment. Yeah, it was about the rules of exponents. And it's the relationship between exponents and multiplication that in many ways creates the rules of exponents. So here you can see that the subtraction is the opposite of addition. Division is the opposite of multiplication. And roots are the opposite of exponents. Okay? Most people are familiar with square roots. So if we say something like the square root of 9 equals 3. Okay, now let's just take a sidebar here for a minute, because in looking at this table, it's clear that the square root of 9 could be positive 3 or it could be negative 3. Okay? And so a lot of people would do this, and they would say positive or negative 3. That's fine. I don't have a problem with that. There is this issue in American mathematics particularly, where they say, if you see this square root symbol with nothing in front of it, that means only the positive square root. And therefore your answer should only be positive 3. I don't really care about that. That's a very artificial thing to me that's completely unnecessary, frankly. And so, however you answer this, if you want to say it's just positive 3, that's fine. If you want to say it's positive or negative 3, that's fine too. I actually taught at a boarding school at one point where we had students from Taiwan, and they had been taught adamantly plus or minus. Don't forget, plus or minus. Because it's true, right? Square root of 9 could be plus 3, it could be minus 3. And so that's why I say that this is an American thing, where people only want the positive square root. I don't really care about that. I'm just letting you know that if you run into this in textbooks or with other instructors, that's where it's coming from. Okay, now we can do other roots. See, I've got this little a in here. Now, this is sort of something that's pretty generally accepted, is that if you just see the root symbol without a number in here, that means square root. Okay? You could say positive 4, you could say plus or minus 4, either way. All right? But now if you want a cube root, okay, like 27, cube root of 27, well, let's talk about what this means for a minute, okay? So why is the square root of 9 equal to 3, let's say, okay? Well, because when you multiply 3 times itself twice, you get 9, all right? That's the definition of a square root. So the definition of a cube root is that we're going to take some number times itself 3 times and get an answer of 27. Well, it happens that I picked the one that is also a 3 here. So 3 times 3 times 3 is 27. That means the cube root of 27 is equal to 3. Okay? Oh, let's do something a little bit different here. Let's get away from using 3 all the time. Let's talk about the 5th root of 32. The 5th root of 32 asks the question, what number times itself 5 times equals 32? Or x to the 5th equals 32. This is asking this question right here. What's x? Well, we just set it up here in this table. That's the whole point of this table, is so that you can see that it's 2 to the 5th power that makes 32. Okay? And you can do the same thing in the same way that you divide on both sides, or you add or subtract something on both sides. We can take a 5th root on both sides, right? The 5th root of x to the 5th is x. And that's equal to the 5th root of 32. And we can simplify that and say that it's 2. Okay. Let's see here. Now we get into this issue of roots of negative numbers. If we want, let's say we want the cube root of 27, we already did that, that's 3. If we want the cube root of negative 27, that's going to be negative 3, right? Because these odd powers work differently, right? Now, let's see. Now let's back up and do, let's say, let's work with 16 here. We do square root of 16, well that's equal to 4 because 4 times 4 is 16. If we do the square root of negative 16, now we kind of run into trouble, okay? Because you don't see any negatives in the squared column, or in the 4th power, or in the 6th power, okay? These always turn out to be positive numbers, and that raised this question for mathematicians over really a period of hundreds of years, where they were like, well, a positive times a positive is positive, a negative times a negative is also positive, so what kind of number can you multiply by itself and get a negative answer? And we'll eventually get to this. We'll talk about what are called complex numbers, which involve this little quantity I, and they're a little bit tricky. But it is really just an extension of our number system, but I will hold off on that until we get to it in the curriculum. All right? So for right now, I just want to talk about these basic ideas of powers and roots. All right? Powers and roots. They work in a very similar way to addition and subtraction, multiplication and division. Okay. So let's look at some problems on the assignment. So in this next set of problems, all we're asking for is to find these roots. Now, problem 2, we kind of go off track right away. The 7th root of negative 10. Well, clearly, if the 2 to the 5th power is 32, we're looking for something raised to the 7th power that's going to give us something like 10. That's going to be smaller than 2, okay? But it's got to be bigger than 1. So this is something that we're going to use the calculator for. So let me get the calculator together and show you this on the graphing calculator. If you have a different calculator, it might work a little bit differently. And if you have trouble figuring out how to do this on your calculator, let me know. All the time I go online and I pull up the manual for students' calculators and I look up how to do certain calculations, and it usually works out pretty well. But let me show you how to do it on the graphing calculator. Let's see here. So let me hold this up. Where is it? There it is. And then we'll get the camera to focus on it. Okay, so in this scenario, you have to go, well actually what you have to do is, well let me just show you first. If you hit that math key right there, now you've got this menu and you can see, there it is. Choice number 4 is a cube root. Choice number 5 is the xth root. Okay? Now, I think on the older calculators, you've got to start out by typing in the 7 first, and then you go into math, and you choose number 5, the xth root. Notice how that 7 all of a sudden jumped up into the radical symbol. That's what we want. We want the 7th root of negative 10. And then we say equals to, and there it is. It's about negative 1.39, I think is a pretty good approximation. So I'll go back up to the board and write that one down. Negative 1.39. And you can test it out, right? Take this number. So there's a couple things you can do here. You can take what we've got here, right, and then just raise that to the 7th power. You'll get exactly negative 10. Now if we take our approximate value, negative 1.39, raise that to the 7th power, we'll get almost 10, right? You can see it's off by, what, 2/100ths? Right there. So pretty close to negative 10, but not exactly. And like I said, if you've got a different calculator and you're not sure how to do this process on your calculator, then let me know. I'll be happy to help you with it. Okay, let's keep going through these then. Problem 4, the 8th root of 6561. So let's see what we get for that one. Yeah, let me show you, with these new calculators, if you've got a graphing calculator that's one of the old 83 or 84s, it's a black color rather than this yellow-orange color, you have to do it the way that I showed you a minute ago, where you put the 7 out in front and then the negative 10 inside, and then it'll calculate it for you. This calculator, these orange ones, will do it either way. So I showed you that way on that last problem. Let's see, I need to get this to focus. There we go. Okay, so what we can do is we can go into math, choose number 5, and then type in the 8 there, and then arrow, see that arrow right there? Arrow into the root, and then you type in 6561, and then hit enter. Oh, and that's 3. Well, that's helpful. And again, you should always be able to test that out. If you do 3 to the 8th power, you should get 6561. Okay, well that's helpful. And this is exactly equal to 3. This means approximately. Okay. All right, problem 6, the 4th root of 36. 4th root of 36. If you look through this x to the 4th column right here, you can see that our answer should fall between 2 and 3, right? 2 to the 4th is 16, 3 to the 4th is 81, so somewhere in between those numbers should be a number that when we raise it to the 4th power gives us 36. So let's see what that is. The 4th root of 36, 2.449. And this is approximate. And there we go. And then problem 8, the 9th root of negative 100. So let's see what that is. All right, 9th root, negative 100, negative 1.668. Okay, so that's that first section, which is just about how to calculate these values using a calculator. Okay? Now, let's look at solving equations that involve powers of a variable and how we can solve those. Okay. Let's see here. Well, problem 2 is pretty straightforward. This is something that we have talked about previously. There's not a whole lot of work here. X to the third equals 27. Like if you know from the table that we just had that 3 to the third power is 27, you can just say x equals 3. All right? If not, the process is undo the power. Undo the exponent by taking a third root or a cube root on both sides. And then you can either know this, get it from the table, use the calculator. Cube root of 27 is going to be 3. All right, problem 4. Now, just like in regular algebra, we want to collect our like terms. 7x to the 5th. So we want to add this over to here. Those cancel out. This will be 12x to the 5th plus 14 equals 3. Subtract 14 on both sides. That's negative 11. And then divide on both sides by 12. So x to the 5th is negative 11 twelfths. And then our last step, oops, that's a pretty interesting looking root symbol. The 5th root of negative 11 over 12. Okay, so now we need to calculate that and get an approximate value. Now, in other situations, instructors might ask you for an exact answer. This is the exact value. Okay, it's not really clear exactly what that number is. Okay, that's why it's kind of nice to get a good decimal approximation. About negative 0.983, let's say. Okay. All right. So this gives us a better idea of what this value actually is. But this one is approximate, whereas this one is an exact representation of that value. Okay. What else? Problem 6. 2x squared minus 4 equals 12. So add the 4 over here. 2x squared is 16. Get the x squared by itself. And then square root both sides. Okay? And so let's see. What is the square root of 8? Square root 8. 2.828 approximately. 2.828. And if you want to say plus or minus, then that's fine too. I think on the answer key for these, I've put plus or minus. Just to remind people that when you're doing an even power, so when you solve something like this, so when you solve an equation, it's important, I think, to get both the positive and negative solutions. Okay? So let's look at the relationship between solution by factoring and solution by rooting. So let's see, if we had something like, x squared equals 25, okay? So if we solve this by factoring, we want to push everything to one side, set it equal to 0, and then we can factor it, right? X plus 5 times x minus 5. And so there we get x could be 5, and here we get x could be negative 5. And this is true, right? Notice that the original equation didn't have that square root symbol, right? So this is the thing I was talking about, is that in a textbook where you see the square root symbol like this, they want you to say it's only positive 3. But notice that that's not the case in these, all right? So when you introduce the square root symbol yourself to solve an equation, then it is important to have the plus or minus in there. Okay, so here's what happens when you're solving by factoring, and you can also solve this by square rooting both sides. But if you do that, it's important to remember to have that plus and minus along with it. Okay, let's look at a couple more here. Let's see here. Problem 8. Problem 8's a little bit tricky. And like I said, we will talk about this later in the term. X to the 6th plus 23 equals 12. So you subtract 23 on both sides, and you get x to the 6th equals what? Negative 11. Well, it depends on what kind of calculator you have and what settings it's on. That's going to determine what you get for an answer. So let's see. I think my calculator should be set up to do this. Yeah, the 6th root of negative 11 is going to give me approximately 1.292 plus 0.746i. Kind of confusing, okay? We're not really going to get into this. Like I said, we'll talk about that later in the term, okay? I don't think I've set up any of the ones that are odd problems to work that way. But when you get an even exponent that's equal to a negative number, you're going to run into that I notation again, okay, those complex numbers. And this is something that happens, you know. I'll save that for the video that I make about complex numbers, okay? All right, go ahead and finish this off. Problem 10. We've got 2x to the 3rd plus 15 equals 125. All right, so let's get that x to the 3rd by itself. Subtract 15 on both sides. 2x to the 3rd equals 110. Divide on both sides by 2. X to the 3rd is 55. So now we want to take a cube root on both sides. And notice with the odd roots, we don't have to worry about plus or minus. Okay? Let's see. Cube root. And there is just a cube root button. You can use that in that math table or in that math menu. This is going to be, x is going to be approximately 3.803. Okay? All right, so that's it for the introduction to powers and roots. And I think it's helpful to think of these as opposite operations, okay, or opposite processes. The root undoes the exponent. Okay, so that's it for this. I think in the next video we will take a look at writing roots in exponential notation. Okay, so as always, if you have any questions about these problems, please let me know.